My name's Bill David, and I'm one of the senior scientists here at the ISIS neutron and muon facility that's behind me. And it's one of the biggest facilities in the UK. I'm also, in fact, a professor of energy materials science at the University of Oxford. And one other thing as well, actually, is I've not done very well in COVID. I've got a paralysed arm and a paralysed chest. But I've managed, actually, over the last few months, to get all the best diagnostic tools there to tell me what's going on. I've had CT scans, I've had X-ray scans, I've had MRI scans actually, and eventually they've been able to detect just exactly which nerves have gone and what's actually happened. And I'm talking about that because that's really important. If you're ill, you want to have the best tools around you to be able to do and get the best prognosis, diagnosis of what's going on. That's exactly what we're doing here with the materials world. So we've got two huge facilities. We've got a synchrotron source called Diamond, about 500 meters away. We've got the ISIS neutron source. And it's a bit like actually saying, well, you know, it's a bit like having a CT scan and an MRI scan. In fact, we really need both because they see our bodies in a different way, in a comparative way, in a way that teaches us more about how our bodies are. With X-rays and neutron sources, then what we can do is actually we can really get into exquisite detail to find out fundamentally how materials work, whether it's ammonia catalysts for cracking, so that we can get ammonia hydrogen combinations that that really will revolutionize the way we bring back internal combustion engines, or we can come up with new types of batteries where we're not just looking at them stationary doing nothing, we're watching them operate, we're watching them degrade, we're finding out about them, and we need X-rays and neutrons to do that. When we're thinking about renewable energy, we're thinking about wind power, we're thinking about solar power, we're thinking about hydroelectric, we're thinking about nuclear as well. But the trouble is, actually, when you've got the sunniest places of the Sahara, so far away from other parts of population density areas, regions, then it's very difficult to transfer and to store that energy. So where I'm researching and what we're talking about here is the whole business of storing renewable energy. And ammonia, believe it or not, actually is an excellent fuel. It's not just a fantastic fertilizer, but it's actually an excellent fuel in its own right. And the thing that it does have that neither batteries nor hydrogen storage has is that it's got a huge, big international infrastructure already in terms of crossing the oceans, 25 million tons of it a year. And so we have that infrastructure, and then it's so huge because basically ammonia feeds half the planet. And if you can actually take a mixture of ammonia and hydrogen, you basically imitate almost perfectly the power that you actually get from running a petrol engine. Here at Harwell and at ISIS, we really are at the crossroads, not just of UK science, not just European science, but world science. We have people coming from across the planet, from the United States, from Japan, from Europe, from South Africa. So there's a huge cross-section of people. And of course, they're here, and they end up talking to each other, and there's many collaborations like that have developed where people who've got that interest in science, a common idea, or sometimes actually a complementary set of ideas, can come and work here and do some fantastic science in world-leading facilities supported by world-leading scientists and engineers.